So welcome back to simple harmonic progressive waves. Simple harmonic progressive wave is basically of two types. दोन प्रकारचे आहेत simple harmonic progressive waves. That is transverse wave. Number one is transverse waves, and number two is longitudinal waves. So simple harmonic progressive waves, you know what is meant by a simple harmonic progressive wave. They are basically primarily classified into two types, that is transverse wave and a longitudinal wave. Now what do you mean by a transverse wave and a longitudinal wave? The wave in which particles of the medium vibrate. Wave म्हणजे disturbance आहे, vibration of the particles आहे. The wave in which particles of the medium vibrate at right angles. कसे? At right angles to the direction of propagation of wave. That wave is called a transverse wave. The wave in which particles of the medium vibrate perpendicular or at right angles to the direction of propagation of wave is called a transverse wave. What does that mean? Suppose this is a wall, भिंत आहे एक, त्याला आपण असा एक दोरा बांधला. A string is tied to that wall. This is the free end. This is the fixed end. दोरा इथं बांधलेला आहे. Suppose A is the fixed end and B is the free end of that string. Now suppose if you give up and down jerks at this point, त्या दोऱ्याला असं वर खाली jerks दिले असे. If you give up and down jerks, then what will happen? A wave means the disturbance will start from here and it will travel in this direction. So a wave will be formed like this. अशी wave तयार होईल. Correct? आता इथं the wave started from B and it went to A, means this is the direction of propagation of wave. Wave started from B and it is traveling towards A. So this is the direction of propagation of a wave. What is the medium through which the wave is traveling? कोणत्या मीडियम मधून वेव ट्रॅव्हल होते? एअर नाही, स्ट्रिंग. String is the medium through which the wave is traveling. आता वेव सुरू होण्यापूर्वी, डिस्टर्बन्स क्रिएट होण्यापूर्वी स्ट्रिंगचे पार्टिकल्स हे असे होते. These were the mean positions of the particles. These are particles of the medium. Medium is string here. Now when the disturbance started, this particle went up to here, this particle here, this one came to here, ha particle itha ala, ha particle itha ala, means all the particles either they moved up or they moved down. So the particles are vibrating in this manner, in this direction. असे vibrate होता है particles. How they are vibrating? Perpendicular to the direction of propagation of wave. This is the direction of propagation of wave and this is the direction of vibration of the particles. So they are perpendicular to each other. So this wave motion is called transverse wave motion, or the wave is called a transverse wave. The wave in which particles of the medium vibrate at right angles to the direction of propagation of wave is called a transverse wave. That is the definition of a transverse. What will be longitudinal wave? Suppose this is a spring which is in equilibrium. It is neither compressed nor stretched. So this is the spring in equilibrium. Suppose it is tied here. Now suppose if you press it from this side, means apply a force, means restoring force, you can say, you apply from this side. What will happen? Due to this force, the particles of the spring, they will come close to each other, isn't it? And further, it will be as it is because of this force. Now, if you take out this force, so force काढून घेतला, what will happen? These particles will move apart. So they will move apart, and while moving apart, they will touch the next particles, and the particles here, they will come close to each other. In this way, if you repeatedly push it and leave it, push it and leave it, then you will see a form like this. म्हणजे कुठे पार्टिकल जवळ आलेले आहेत, कुठे दूर दूर गेलेले आहेत. So here, this is the direction of propagation of wave. The disturbance started from here and traveled in this direction. So this is the direction of propagation of wave. And particles of the medium is spring here. They are either moving forward or backward. Means vibration of the particles is parallel to the direction of propagation of wave. This wave is called longitudinal wave. The wave in which particles of the medium vibrate parallel to the direction of propagation of wave is called a longitudinal wave. That is the definition of a longitudinal wave. So this is a longitudinal wave, and the wave on a string was transverse wave. Similarly, suppose if you consider air, undisturbed air. Suppose these are the layers of undisturbed air. Disturbance झालेलं नाहीये, wave आलेली नाहीये. The layers are at equal distances from each other. If a force is applied here, what will happen? The layers will come close to each other at this point. The force is removed. What will happen? The layers will move apart, and they will push the layers here so that they come close to each other. In this way, if you repeatedly push it and leave it, then here the wave layers have moved apart, came close, moved apart, came close. Correct? Means this is the direction of propagation of wave. आणि मीडियमचे जे पार्टिकल्स आहेत, एक तर पुढे जात आहेत किंवा मागे जात आहेत. So this is which wave? A longitudinal wave. The wave in which particles of the medium vibrate parallel to the direction of propagation of wave is called a longitudinal wave. So the simple harmonic progressive wave is of two types: transverse wave and longitudinal wave. Now let us see their characteristics, their properties. Transverse waveच्या properties काय आणि longitudinal waveच्या properties काय. Let us begin with transverse wave. The first characteristic, first property of transverse wave is its definition. त्याची definition ही त्याची पहिली property आहे. काय असणार मग ते? The first characteristic of transverse wave is, in a transverse wave, particles of the medium vibrate कसे? Perpendicular to the direction of propagation of wave. That is first characteristic, first property of a transverse wave. Number one, in a transverse wave, the particles of the medium vibrate perpendicular to the direction of propagation of wave. Then, in a transverse wave, particles vibrate perpendicular. We took the example of the string. So this will be a transverse wave, isn't it? This is direction of propagation of wave. This is vibration of the particles. This part is called crest. काय म्हणतात याला? Crest. And this part is called trough. So in a transverse wave, crests and troughs are produced. Second characteristic. In a transverse wave, crests and troughs are produced. The convex portion is called crest and the concave portion is called trough. That is second property, second characteristic of a transverse wave. In a transverse wave, crests and troughs are produced. The convex portion is called crest and the concave portion, convex, concave, concavity, cavity वरून concave, concavity. So the convex portion is called crest and the concave portion is called trough. Second property. Crests and troughs are alternately produced in the medium. Crests and troughs are alternately produced in the medium. म्हणजे crest च्या नंतर trough, परत crest, परत trough. Crests and troughs are alternately produced in the medium. And the next characteristic says, crests and troughs are successively produced at the same point of the medium. दोन वेगवेगळ्या प्रॉपर्टीज आहेत. पहिली प्रॉपर्टी काय होती? क्रेस्ट अँड ट्रफ्स आर अल्टरनेटली प्रोड्यूस्ड इन द मीडियम. म्हणजे क्रेस्टच्या नंतर ट्रफ, ट्रफच्या नंतर क्रेस्ट, क्रेस्टच्या नंतर परत ट्रफ, ऍट द सेम मोमेंट, ऍट द सेम इन्स्टंट. नेक्स्ट प्रॉपर्टी सेज crest and troughs are successively produced at the same point of the medium. What does that mean? Suppose this is the wave. Here, crest has been produced. All the particles have moved up. आता ते तिथंच राहणार आहेत का? नाही. They are performing oscillation. म्हणजे हे सर्व पार्टिकल्स काय होणार आहेत? असे ऑसिलेट करत करत खाली येणार आहेत आणि मग इथंच काय तयार होईल? ट्रफ तयार होईल. इथे ट्रफ आहे. हे सर्व पार्टिकल्स ऑसिलेट होत आहेत. ते आता वर जाणार म्हणजे तिथंच परत काय तयार होईल? क्रेस्ट तयार होईल. म्हणजे जिथं क्रेस्ट होतं त्याच पॉइंटवर पुढच्या क्षणी काय तयार होईल? ट्रफ. आणि जिथं ट्रफ आहे तिथं क्रेस्ट. सो क्रेस्ट अँड ट्रफ्स आर सक्सेसिव्हली प्रोड्यूस्ड ऍट द सेम पॉइंट ऑफ द मीडियम. सो दीज आर टू डिफरंट कॅरेक्टरिस्टिक. याच्या आधीची प्रॉपर्टी, crest and troughs are alternately produced in the medium. Crest च्या नंतर trough, trough च्या नंतर crest, crest च्या नंतर trough at the same moment. त्याच वेळी तुम्ही वेव्ह कडे बघितलं तर crest आहे, crest च्या नंतर trough आहे, त्याच्यानंतर परत crest आहे, परत trough आहे. Crest and troughs are alternately produced in the medium at the same instant. And next characteristic says crest and troughs are successively produced. Successively produced, एकानंतर एक, at the same point of the medium. So, number 5, the distance between two successive crests or two successive troughs. एकानंतरचे नंतर एकचे असे दोन क्रेस्ट मधलं अंतर किंवा एकानंतर एक दोन ट्रफ मधलं अंतर, it is called wavelength lambda. The distance between two successive crests or two successive troughs is called wavelength lambda. That is the fifth characteristic of a transverse wave. The distance between two successive crests or two successive troughs is called wavelength lambda. Then the next characteristic says the period, frequency and amplitude. Period, frequency and amplitude is same for every particle of the medium. Period, frequency and amplitude is same for every particle of the medium. Means what? Suppose if you consider this wave, प्रत्येक पार्टिकल कोणत्या मोशन मध्ये आहे? ऑसिलेटरी मोशन मध्ये आहे. प्रत्येक पार्टिकल ऑसिलेटरी मोशन मध्ये आहे. प्रत्येक पार्टिकलला एक ऑसिलेशन पूर्ण करण्यासाठी तेवढाच वेळ लागेल. मीन्स पीरियड इज सेम फॉर एव्हरी पार्टिकल. प्रत्येक पार्टिकलचे नंबर ऑफ ऑसिलेशन्स पर सेकंड तेवढेच होणार. एका पार्टिकलचे सेकंदात जेवढे ऑसिलेशन झालेत प्रत्येक पार्टिकलचे एका सेकंदात तेवढेच ऑसिलेशन होणार, म्हणजे त्यांची फ्रिक्वेन्सी सेम आहे. सो पिरियड इज सेम, फ्रिक्वेन्सी इज सेम, अँड व्हॉट इज सेम, एम्प्लिट्यूड इज ऑल्सो सेम. कसं? आता समजा ही वेव्ह आहे, अगेन हा पार्टिकल इथं आलाय, म्हणजे हे त्याचं एम्प्लिट्यूड आहे. हा पार्टिकल इथं आलाय, इथं आहे. मग या दोघांचं एम्प्लिट्यूड सेम आहे का? याचं आणि याचं दोघांचं एम्प्लिट्यूड सेम आहे का? हो आहे. कारण हा पार्टिकल सध्या इथं आहे, तो इथंच राहणार आहे का? नाही, तो वर जाणार आहे. आणि कुठपर्यंत जाईल तो? जेवढा हा पार्टिकल गेला तेवढाच जाईल आणि तेवढाच खाली येईल. राईट. सो एम्प्लिट्यूडचा अर्थ काय आहे? मॅक्सिमम डिस्प्लेसमेंट. सध्या तो पार्टिकल इथं आहे, ही त्याची एम्प्लिट्यूड नाहीये, ही त्याची डिस्प्लेसमेंट आहे. त्याची एम्प्लिट्यूड किती आहे? एवढीच. So amplitude is also same for every particle. So period, frequency and amplitude is same for every particle of the medium. Then the next characteristic says that when a transverse wave is produced in the medium, the density, pressure, etc. of the medium, they do not change. मीडियमची डेन्सिटी, प्रेशर वगैरे चेंज होत नाही. फक्त काय चेंज होतो? मीडियमचा शेप चेंज होतो. द डेन्सिटी, प्रेशर ऑफ द मीडियम रिमेन सेम, दे डू नॉट चेंज. नेक्स्ट कॅरेक्टरिस्टिक सेज that for the propagation of a transverse wave, the medium should possess elasticity of shape. Medium should possess elasticity of shape. What does that mean? If you take the example of transverse wave on a string, string is the medium. तुम्ही इथे अप अँड डाऊन जग्स दिले तर अशी वेव्ह तयार झाली. इथे मीडियम काय आहे? स्ट्रिंग. व्हेन द वेव्ह इज प्रोड्युस्ड, मीडियमचं काय चेंज झालं? त्याची लेंथ चेंज झाली का स्ट्रिंगची? नाही. त्याची थिकनेस चेंज झाली? नाही. डेन्सिटी चेंज झाली? नाही. स्ट्रिंगचा मास चेंज झाला? नाही. नथिंग. देन व्हॉट चेंज? ओनली शेप चेंज. फक्त स्ट्रिंगचं काय चेंज झालं? शेप चेंज झालं. मीन्स फॉर द प्रोपगेशन ऑफ अ ट्रान्सवर्स वेव्ह, the medium should possess elasticity of shape. मीडियम मध्ये कोणती इलास्टिसिटी पाहिजे? शेपची इलास्टिसिटी पाहिजे. मीन्स मॉड्युलस ऑफ रिजिडिटी. यू हॅव स्टडीड इलास्टिसिटी. It should have elasticity of shape, means the medium should possess modulus of rigidity, which is the property of only solids. Liquids and gases, they don't have shape, so they don't have elasticity of shape, they don't have modulus of rigidity. Means the transverse waves can travel only and only through solids. कारण ट्रान्सवर्स वेव्ह ट्रॅव्हल होण्यासाठी मीडियम मध्ये पाहिजे इलास्टिसिटी ऑफ शेप, म्हणजे मॉड्युलस ऑफ रिजिडिटी पाहिजे, विच इज द प्रॉपर्टी ऑफ ओनली अँड ओनली सॉलिड्स. लिक्विड्स अँड गॅसेस डू नॉट हॅव शेप or elasticity of shape. Therefore, transverse waves can travel only and only through solids. They cannot travel through liquids and gases. So that is next characteristic of transverse waves. Transverse waves can travel through solids and they can also travel through the interface or over the interface. म्हणजे काय? की समजा पाणी आहे, liquid. Can transverse wave travel through it? No. Transverse wave can travel only through solid. पण surface वरती हा जो surface आहे, this is the surface separating water and air. This is called interface. काय म्हणतात याला? Interface between two media. दोन मीडियम मधलं इंटरफेस. इथं जी वेव्ह असेल ती असते transverse wave. So transverse wave can travel through solid and they can travel over the interface. They cannot travel through liquids and gases. That is the property of a transverse wave. And the next property or the last property says the transverse wave on a string, जर string वरची transverse wave आपण consider केली, specific condition, the velocity of transverse wave on a string is given by v is equal to under root t by m. The velocity of transverse wave on a string is given by v is equal to under root t by m, whereas t is tension in the string, and m is mass per unit length. m mass नहीं है, m काय आहे, mass per unit length of the string, म्हणजेच m by l of the string, mass per unit length of the string, which is also called linear density. मास पर युनिट लेंथला काय म्हणतात आणखीन, लिनियर डेन्सिटी. सो velocity of transverse wave on a string is under root t by m, whereas t is tension in the string and m is mass per unit length of the string, also called linear density of the string. Then the last characteristic, one more, the transverse waves can be polarized. The transverse waves can be polarized. आता हे polarization म्हणजे काय हे आपण पुढे शिकणार आहोत. So at present we don't go into it. Just remember the word. The transverse waves can be polarized. Okay. So these are the characteristics of transverse waves.